Mark your own. Here we go. There are some nasties here. Good old Anne. Try what right now? I heard physics talking there, I think. Did I or not?
Yeah.
Okay. What are you trying to figure out?
We look for the bonus sensor.
Oh, we'll find out. You know what? I look at number 1, I see a collision. This is probably a job for conservation momentum. I see norths and souths and east. I see angles. So I say, okay, this is going to be a tougher question. I think first of all, I'm going to go draw compass rose. And I'm going to say, all right, the sum of all the momentum before the collision equals the sum of all the momentum after the collision. Before the collision, what's moving? Mass 1, mass 2, or both? Oh, both. Since I see a truck and I see a car, instead of using 1 and 2, which is fine, by the way, I'm going to use C and T. C for car, T for truck. Momentum of the car, momentum of the truck. Wham! They collide. After the collision, what's moving? Car, truck, or both? Both. Stuck together or separate? Ooh, stuck together. Fancy word for stuck together? Inelastic, right? Momentum, both. Final. I'm going to draw a little picture. Let's see. Car is moving east. And its mass is 1,200. Its velocity is 30. I think I can safely say that someone's late for my class. Let's see what we got here. Continue on. Mass times velocity. Well, if it was 1,200 times 3, it'd be 3,600. There's an extra 0. You know what, Cliff? I don't think I need a calculator to do that one in my head. I don't know why I'm picking. It was, oh yeah, there was one a few weeks ago where it was like a 1 or a 0 times table or something silly like that, wasn't there? Okay. Anyways, 36,000, yes? Plus, okay, 60 degrees north of east. So there's east. There's 60 degrees north of east. It's going to look like that. And it's 3,600 at 20. You know what? It's 72,000. Now, this is terrible scale. I'll make sure when I actually draw the triangle that 72,000 is about twice as long as that 36,000, I hope. Equals, well, I don't know. They didn't tell me. They just said they interlock and move off together. But Petra, the nice thing is I know both vectors that I am adding, and I can't add them tip to tail, so I'm pretty sure this is going to look okay. My triangle is going to look something like this. I'm going to have 36,000, and then up at a 60-degree angle and about twice as long, 72,000. I'm pretty sure that there is the resultant. Oh, and they told me that this angle is 60 degrees, which means this angle here must be 120 degrees. I've got an angle inside my triangle. Pretty clearly not SOHCAHTOA. Cosine law. How much room did I leave? Boy, not much. Cosine law is going to be the momentum of both squared equals 36,000 squared plus 72,000 squared minus 2. 36,000. 72,000 cos 120. I'm going to get the momentum of both equals 36,000 squared plus 72,000 squared minus 2 minus Mr. Dueck times 36,000 times 72,000 cos 120. Wow. Oh, square root. 95,247, 95247. I want to change that into a velocity. That's going to be 95247 divided by, I guess, the mass of what? I guess of both of them, Sam, because they're stuck together, yeah? 1,200, 4,800? Hopefully I get something that looks about right. 19.8, yeah, I'm good with that, because the original one was going 30, the second one was going 20, so we are in the ballpark. I don't think I've made a mistake. Is the magnitude 19.8? People nodding? So, 19.8 meters per second at, now I need to get a direction. Well, there's my theta. I think it's going to be sine theta over 72,000 equals the sine of 120 over 95247. It's going to be 72,000 times the sine of 120 divided by 95247. Inverse sine of that. Do you get 40.9 or 41 degrees? 40.9 degrees? What of what? What of what? South of west? North of south? East of west?
North of east.
I think it's north. Is it north of east? Yeah? Or I would take 49.1 degrees east of north. Now, if you got that, you get 4 out of 4. Otherwise, here's how I would give out part marks. I hope. What version quiz is this? What does it say at the top? Quiz V. Version 1? Momentum quiz 1. Quiz 2, version 1 answers. Please tell me I have an answer key showing my mark breakdown. So, probably something like this. I'd give you a half mark just for recognizing, hey, it's momentum. Give you a half mark for a good, 1 whole mark if I saw the vector triangle. Half mark for the finding momentum, and then 1 mark for the velocity, speed, and then 1 mark for the direction to turn it into a velocity. But that's, again, if you didn't get the right answer. That's where I would look for. If you got that, that means as long as you're careful, Bree, you'll get 7 out of 7 on a written question. Because there's going to be one, hey, there's going to be 2 vehicles, one's moving, one's not, or both moving stick together, or at yucky angles. Number 2, the ballistic pendulum. A pendulum is hanging from a frictionless, massless string. The pendulum weighs 2.5 kilograms. A bullet is traveling at by the way, the string length of 15 meters, I don't think I'm going to use it all, but I had to add that because I think this one goes up fairly high. And I think the first time I made up this question, it went up higher than the string would allow it. So anyways, bullet hits and sticks, what height? So I think we said we divide this into 3 sections. Collision, no, not 3 sections, 2 sections. Collision, and then how high it swings. I think we divide this into energy, no, collision, Mr. Dueck. Momentum, and then how high it swings. Energy. I think we can say the sum of all the momentum before equals the sum of all the momentum after, because the bullet collides with the pendulum. I'll use B for bullet and P for pendulum. Before the collision, what's moving? The bullet. After the collision, what's moving? Both stuck together. So it's going to be M bullet, V bullet equals M bullet plus M pendulum, V final. I think the speed after the collision is going to be the mass of the bullet, speed of the bullet, divided by the mass of both. Fancy word, inelastic collision. Bullet, 0.15. Speed, 250. Mass of both, 2.65. 0.15 times 250 divided by 2.65. You get 14.15, and I'll carry a few extra sig figs, so I'll go 14.151. Oh, sorry. Why did they collide? I forgot that. My bad. I could see some of you were just, wondering when it was going to occur. Energy. Kinetic initial, potential initial, kinetic final, potential final. And I think I can say starts out on the ground and comes to a stop. I think I can say a half mv initial squared equals mgh final. Yay! That's kind of convenient. I think I can say the final height looks like it's going to be v initial squared divided by 2g. It's going to be 14.151 squared divided by 2 times 9.8. It's going to be this squared divided by bracket 2 times 9.8. Do you get 10.2? Yep. So I don't know if you remember, the one that we did in our example had bad numbers. I think the block ended up moving like a half a centimeter. Hey, this one would be easier to spot. It would swing way up. It would swing up 10.5 meters. There would be a good impact and a good swing after the bullet stuck into it. 10.2, what did I say, 5? I said 2 and I wrote 5 because apparently my brain functions strangely. In terms of part marks, so full marks if you got the 10.2. Otherwise, I would give you a half mark if you recognize that it involved momentum. Another half mark if you recognize it also involved conservation of energy. Half mark if I saw that equation. 1 whole mark for finding V final after impact. That would get you 2 out of 4. And there's the rest. So in theory, Jordan, this is going to get 10.2 meters in the air. What if it doesn't? Well, then that extra energy must have gone into deforming the wood and heat and whatever else it took. So for the bonus question for 1 whole mark, suppose it only reached a height of 5 meters. How many joules of energy were lost to the heat? Okay, so now we can say this. Kinetic energy initial, potential energy initial, kinetic energy final, potential energy final, and heat. I still think that we're starting out on the ground. I still think we're coming to a stop. It looks like the heat is going to be your kinetic energy initial minus your potential energy final. I think the heat is going to be a half mv initial squared minus mgh final. This time the masses don't cancel. It's going to be a half the mass of both, which was 2.65, v initial, which was v final after the collision, 14.151 squared minus 2.65, 9.8, 5. 0.5 times 2.65 times 14.151 squared minus 2.65 times 9.8 times 5. Do you get 135 joules? It's a bonus question, so it's kind of all or nothing. Now, the other day, I think it was Michael, somebody was saying, Mr. Dueck, couldn't I just find the change in potential energy, and wouldn't that be the heat? So you're saying last time it went 10.2, this time it went 5. You're saying, Mr. Dueck, couldn't I go mass, try that again, mass times 9 mg final minus mg h initial. What was my initial height? What did we actually get? 10.2? Yeah. You know what? I got it right here. I'm going to go 10.216, and I'll go 8 because that's a 9. That's a good place to round off. Yep. Oh, the negative here is saying you lost some potential energy because I did go final minus initial. So yeah, whoever was asking, that does work as well, it looks like. I think the reason that we weren't getting that initially, we were a tiny bit off, might have been rounding off too soon, which is why I carried like 6 figs in my height initial. For some reason on Friday, I couldn't see that, but I was tired Friday. Number 3. 125 kilogram shell explodes, boom, into 3 fragments. Fragment A weighs that much, flies off that direction. Fragment B weighs that much, flies off that direction. Find fragment C. There's going to be an explosion on your test. Sorry. There's going to be a question where you solve an explosion on your test. I really should phrase that carefully. It's going to be almost identical to number 3, except I think what I did on your test was I made them fly off at nice right angles. In other words, they didn't fly off so many degrees east of what they fly off due north or due south or due east or due west. And the only yucky angle is the one that you're finding. But the rest of the triangle Kelly is lovely SOHCAHTOA. In other words, this one is fair game, except it's a little harder than I feel comfortable throwing at on your test. Is there an explosion? Is there a jeune? This is a job for conservation of momentum. Why is this an explosion and not a collision? What did I say was special about an explosion? Well, it turns out in an explosion, your momentum is 0, which means your final momentum is 0, except I'm not going to put 0 equals 0. On the right-hand side here, I'm going to dulp. It says, you know what? Since I've turned the page and I see 2 sets of directions, I better draw that. Fragment A flies off 30 degrees north of east. There's east. There's north of east, 30 degrees. Actually, I'm dulping before I wrote this, sorry. I think I told you guys before you do that, you should write momentum A, momentum B, momentum C. Stuck together or separate? All separate. Now I can dulp. So fragment A, go east, go 30 degrees north of east. How big? Mass times velocity. 75 times 32. 2,400. Plus fragment B, north of west. So go west. Go north of west. That way, how many degrees? 20 degrees. How big? Mass times velocity. Well, 4 times 48 would be 192, I think 1,920, but let me double check. Aha, good. Plus, don't know. This is about as tough a vector diagram as you'll ever get. I mean, it starts out okay. Do I have 2 vectors to add together? I do. How will I add them together? Why, I draw them tip to tail, so it's going to look like this. $2,400, slightly shorter, $1,920. I guess the resultant, because my momentum is 0, that there is my resultant. Now, I'm not sure about this triangle. It may be that I should have drawn this line a bit further. It may be that I should be pointing down that way. I'm going to have to trust the trig will tell me what's right. This is a really, really tough one. I think that I have drawn this a little bit shorter than that. I have a feeling that the third momentum is going to be a little south and a little west as opposed to a little south and a little east. But Claire, I'm not sure yet. Got to get some angles. Okay. Well, they told me that... Dope, didn't want to do that. Dope, didn't want to do that either. Come back. They told me that this angle here is 30. They told me that this angle here is 20 degrees. How's that help? See it? Okay, so how big is this little angle right here? 30, and so I heard somebody say it. How big is this whole angle? 50. Turns out this interior angle right here is going to end up being, that's one of the reasons this is such a tough triangle. You can only find two halves of a strangely located angle. But that's a good angle. Now I think I'm good to go for the cosine law. Whew. I think I can say this. Momentum of object C squared equals 2,400 squared plus 1920 squared minus 2 2,400 1920 cos 50. 2,400 squared plus 1920 squared minus 2 2,400 1920 cos 50. Square root. And I get a final momentum of 1876.82. Object C is moving at 1876 point, what did I say, 82? How can I turn that into a speed? Divide by the mass. And the mass of object C is, they didn't tell me. Or did they? How can I figure out the mass of object C? Really? Okay, I think I actually did that on the test as well. I think on the test I gave you the overall mass and then 2 of the small masses. So yeah, we're going to have to go, I guess it's going to be 125 minus fragment A minus fragment B. Fragment C, only 10 kilos. Is that right? Yeah? So it's going to be 1876.82 divided by 10. Even Cliff can do this in his head, right? Yeah. Divide by 10, what do you get, my friend? Which would be the 4 sig figs. So because I'm a good student, I'm going to go to 3 sig figs and call it an even 188. I'm going to say meters per second at bleh. Bleh. Well, it looks like this is where I'm coming from. But am I actually going to use that particular angle? No. Why? Because it's next to a slanty and it's next to a slanty, so it's nothing of nothing. It's not north of south or east of west or what of what. I'm going to need to find that angle, but I think I'm going to have to combine it with maybe that angle there, which I think is 20 degrees if I extend my Z. And even that's not going to be all the way what I want, but we'll see here. Okay. Oop. Sine theta over 2400 equals sine 50 over 1876.82. Theta is going to be 2400 sine 50 over 1876.82. It's going to be 2400 sine 50 over 1876.82. Inverse sine of that, 78.4 degrees. So this angle here is 78.4 degrees. The problem is if I add those two together, what do I get? If I add these two together, 98.4, bigger than 90. Now, if you said 98.4 degrees south of east, I'll take it. But I think if this angle here is 98.4 degrees, how big is that angle there? I think I can go 81.6 degrees south of west. So I'd take that. 81.6 degrees south of west. Or, of course, I'd take 8.4 degrees west of south. In terms of part marks, let me double check, is that right? I hope. Woohoo! So 81 degrees south of west, or 9 degrees, what did I say, 8.4? 8.4 degrees? Okay, some rounding. I'd take 82 degrees here, actually, I think. Maybe I used the 100. Oh, I went to 1876. I should have carried a few extra sig figs, apparently. In terms of part marks, I would give you a half mark if I saw that. One whole mark for a good vector triangle diagram. Half mark for that. 1 mark for the speed. Half mark for the theta. Half mark for the what of what. Can you give yourselves a score out of, count them, 12? If you didn't do the quiz because you were away, please put a big omit at the top where their score is. Test will be Monday, I think, but I'll let you know for sure on Wednesday. Okay? I'm done the unit. I'm going to give you, holy smokes, 45 minutes to work on the big review. You guys are ahead of the game compared to my other classes, so be happy. Consider yourselves lucky and fortunate.